Hello, myself Sheetal Vishwakarma from MTech IIPS DAVV Indore, India. In this video lecture, I am going to explain algorithm of predictor-corrector method. First of all, first check what is predictor-corrector method. This is a method for calculating numerical solution of differential equation. This solution is curve g of x, y in x, y plane, whose slope at every point x, y in the specified region is given by the equation dy by dx equal to f of x, y. The initial point x1, y1 of the solution curve and the slope at the curve at this point are given. With this information, we are asked to extrapolate the value of y for the set of values of x in the range x1, xf. Xf is the final value of f for which we have to generate the graph. Euler's formula for the solution of differential equation is given by yi plus 1 equal to yi plus hf of xi, yi. Euler's formula for the solution of differential equation is given by yi plus 1 equal to yi plus h by 2 into si plus si plus 1. Si is the slope of straight line at xi, yi, and si plus 1 is the slope of straight line at xi plus 1, yi plus 1. Si equal to f of xi, yi, and f of si plus 1 equal to f of xi, yi plus si plus h. Y of I plus h for Si plus h is obtained from Euler's formula. In the above method, yi plus 1 is in solution is evaluating using only point yi and none of the previous point. But in predictor-corrector method, we will use previous point, so it is more accurate. It will give more accurate answers. Solution at xi plus 1 are found to be yi, yi plus 1. Solution at xi plus 2 may be extrapolated from yi and yi plus 1. Now let's assume that the curve that we have to find is a quadratic curve. Then y equal to a plus b into x minus xi plus c into x minus xi into x minus xi minus h. The coefficients a, b, c may be obtained by the following equations. First equation is y equal to yi and x equal to xi. That is when x equal to xi, y equal to yi. Second equation says that y equal to yi plus 1 at x equal to xi plus h. H is the interval between first value and the next value of x. dy by dx of xi plus 1, yi plus 1 equal to f of xi plus 1, yi plus 1. This is our third equation. By substituting equation 1.1 in quadratic, we will have value for a equal to yi. Similarly, for values of b and c, substitute equation 1.2 and 1.3 in quadratic respectively. Now we will get b equal to yi plus 1 minus yi upon h, c equal to 1 upon h f of xi plus 1, y of I plus 1 minus yi plus 1 minus yi upon h square. Using these values of ABC, value of y at xi plus 2 may be obtained from quadratic equation as value of y at xi plus 2 is called as yi plus 2 predicted as yi plus 2h into f of xi plus 1, yi plus 1. This is our equation 1.4. The superscript p indicates that y of I plus 2 p is an extrapolated or predicted value. This is a graph showing function at xi plus 1, yi plus 1 and xi plus 2 and yi plus 2. B is the area between these two graphs. A check on whether this prediction is reasonable may be done by examining the plot of the derivative dy by dx. This is our graph. y of x has been assumed to be quadratic, we may assume dy by dx to be linear. As we have assumed y of x to be quadratic, we may assume it is clear that dy by dx is linear. The area under the curve b upon w xi plus 1 the area between the curve xi plus 1 and xi plus 2 may thus be evaluated using trapezoidal rule. This area is b equal to h upon 2 f of xi plus 1 comma yi plus 1 plus f of xi plus 2 comma yi plus 2 predicted. Another estimate of yi plus 2 may be obtained by adding this area b to yi plus 1. This value is yi plus 1 corrected equal to yi plus 1 yi plus 2 corrected equal to yi plus 1 plus h by 2 f of xi plus 1 comma yi plus 1 plus f of xi plus 2 comma yi plus 2 predicted. So from this equation we will get corrected value of yi plus 1 using the predicted value of yi plus 2. We will get corrected value of yi plus 2 in this equation. Equation 1.4 and 1.5 constitute a predictor-corrector method of developing the solution of differential equation from xi, yi and xi plus 1, yi plus 1 to xi plus 2, yi plus 2. Now, algorithm for predictor-corrector method can be given by first we have to read initial values of x and y and the common interval between them, that is h, and the final value of x, that is up to which we have to iterate. First we have to write value of x1 comma y1. In this algorithm we have calculated y2 with the help of Hume's method. First of all, s1, that is slope at x1 comma y1 can be given by s1 equal to f of x1 comma y1, x2 equal to x1 plus h, y2 equal to y1 plus hs1. This is obtained by Euler's method. s2 equal to f of x2 comma y2 and again y2 equal to y1 plus hs1 plus h2 upon 2. This is obtained by Hume's method. Now while loop is there from x2 to xf, means while x2 is less than or equal to xf, this while loop will be executed. First of all, we will write x2 comma y2. First of all, we will calculate s2 equal to f of x2 comma y2 and we will calculate y3 predicted using s2. This is y1 plus 2hs2. y3 equal to y2 plus h. s3 equal to f of x3 comma y3 predicted. Then y3 corrected can be given by y2 plus h of s2 plus s3 predicted upon 2. Now putting value of y2 in y1 and y3 corrected in y2 and value of y3 in x2. In value of x3 in x2. Now there is end of while loop and end of algo. Let's check our algorithm with the help of example. We are given with the slope dy by dx equal to minus x into y. Initial value of y is 0 and initial value of y is 1 and initial value of x is 0, that is x1 equal to 0 and y1 equal to 1. We know that y3 predicted can be given by y1 plus 2hs2 and y3 corrected value can be given by y2 plus h into s2 plus s3 predicted upon 2. This solution is started using Hume's method. First of all, we will calculate y2 with the use of Hume's method. We are given with x1 equal to 0, y1 equal to 1 and xf equal to 0.25 and h equal to 0.05. First of all, s1 equal to minus x into y, minus x1 is 0, y1 is 1, so s1 equal to 0. x2 equal to x1 plus h means 0 plus 0.05 means 0.05 is x2. y2 can be calculated as y1 plus hs1. That is, y1 is 1 plus h means 0.05 into s1. S1 is 0. So y2 equal to 1. Now we will calculate s2 equal to f of x2 comma y2, that is f minus x2 into y2. x2 is 0.05 and y2 is 1. So s2 equal to minus 0.05. Now s1 plus s2 upon 2 is equal to minus 0.025. y2 can be obtained as y1 plus h into s1 plus s2 upon 2. So here y1 equal to 1 plus 0.05 means h into s1 plus s2 upon 2 equal to minus 0.025. So y2 equal to 0.999. Now by predictor-corrector formula, x1 equal to 0, y1 equal to 0, x2 equal to 0.05 and y2 equal to 0.999. Now using step 10 from algorithm, we will get s2 equal to minus x2 into y2, means minus 0.05 into 0.999 equal to minus 0.04995. y3 predicted can be obtained as y1 plus 2hs2. H 2h means 0.05 into 2, that is 0.1, and s2 is minus 0.04995. So y3 predicted is 0.995005. x3 is 0.1, that is 0.05 plus 0.05 equal to 0.1. s3 can be calculated as minus x3 into y3 predicted. x3 is 0.1 and y3 predicted is 0.995005. That is, s3 is given by minus 0.0995. Then y3 corrected value is equal to 0.999 plus 0.025 into s1 plus s2. Sorry, s2 plus s3. s2 equal to minus 0.04995 and s3 equal to 0.0995, which is so y3 predicted can be given by 0.9953. So this loop will continue till x2 is less than equal to xf, that is from 0.2 to 0.25. So thanks for watching this video.